So all of what we do is intended to be hardware agnostic, right? We don't necessarily dictate exactly what hardware we want to use. And also, we are software agnostic. All of our software lives on the fabric. When we compose a bare metal machine for you, run whatever you want on it. You want to run a bare metal OS, run a bare metal OS. You want to run a hypervisor, run a hypervisor. You want to run VMware, it doesn't matter to us. We will provide the API to the application layer, so the application layer can come in and start making decisions on what it wants the hardware to look like and how it wants the hardware to be reconfigured. This means we're out of the data path, right? I'm not in the data path, so I'm not a performance bottleneck. I am the orchestrator sitting in the background, making connections between the different devices on the fabric, and then I'm out of the way.
Are there any use cases here that wouldn't be recommended?
That's a fair question, right? This is a new tool. It's a new hammer, and if someone wants to drop the hammer on their foot, they could drop the hammer on their foot. So there are methods that we try to say, hey, you're about to remove a GPU from a running machine. Are you sure you want to do that? And if the customer says yes, then we'll go ahead and do it. The good news is GPU hot plug works. I can add and remove GPUs from running machines, and that works. So yes, there are certain environments where you have to be careful in the sense of by taking a device away and the application wasn't ready for it, and that bad things could happen, but that's kind of what comes with the new tools that you're given, right?
So then it's up to the customer to understand what capabilities their OS, their applications have, and that sort of thing in terms of being able to rip and replace hardware underneath that OS.
Dynamically on the fly, right? If you go ahead and remove a GPU while your application's running and your application barfs, you should have taken more care before you have taken that action, right? But not giving the customer the capability because they might do something wrong, that doesn't work either, right? We have to give them the capability, and then we have to train them that this is the new way of doing stuff, and we put the preventions in place inside of our environment that says, you're about to take this action, are you sure that you really want to take this action? We can put those safeguards in place, but it's the same thing with many of today's environments. If I walk up to a server and if I rip an SSD out from the front of that box when the application is running, yeah, bad things can happen. So don't do that, right? And so that's what we try to educate the customer on. It is a new tool, right?
So then the same thing with storage. If I just grab more disk from from some other resource and I add it in, then
we have demarcation. And when we get to the video of the software demo, I'll show you how we demarcate. So engineering is not stealing HR's resources, and accounting is not giving their SSDs to the DevOps group, right? So we'll explain how multi-tenancy works in our environment. But from a high level, we have a free pool. From the free pool, we grab devices and we put them into groups. A group for this part of the organization, a group for that part of the organization. And then inside the group, we create as many machines as we want. And when I want to modify my machine, I can only take a resource that's been assigned to that group. That's how we handle the multi-tenancy part of it, right? Okay. All right, so guys, as mentioned, we don't make any of that hardware out there, right? Very much our route to market is through partnership. One of the things that we are announcing at the show here this week is, in fact, the announcement came out this morning, is Liqid has been selected to be a Dell OEM solutions partner. So now Dell will be carrying Liqid composable solutions under the Dell umbrella, and customers are going to be able to buy those solutions directly from Dell. So it is a massive achievement for us as a company to be able to get here. We're very excited about this partnership. And we think we're going to be able to get this tech in front of a lot of important customers and start educating the market about the benefits of composability. So we're very excited about that partnership, and Bob can send you guys the press release if that's interesting. And as part of that press release, there's part of this initial launch, there's 3 products that we're going to be announcing with the Dell team. That's our route to market, guys, right? We want to not only give the easy button to the customer as far as their hardware choices and, you have to use this SSD or that SSD. We want to make it agnostic. We're software agnostic, right? And then we also want to give the customers the easy button on procurement. When our customers are able to buy from Dell, I'll be honest with you, they feel better, right? They feel good buying from the largest IT company in the world, and we want to enable their procurement team to continue to do that, right? These are some of the areas that we are actually chasing as far as use cases go for our solution. The first and a very important one is around this AI, machine learning, deep learning vertical. Basically, any environment that's leveraging FPGA and GPU, we're a natural fit for that. There's 3 things that we do special for GPUs that we believe a lot of people aren't doing. Number 1 is this idea to scale out GPUs. So if my server needs 4 or 8 or 16, we can enable that by scaling them out across the fabric. The next thing that we enable is the dynamic reallocation of these resources, like the media customer we have. Give them to this person during the day, give them to that person at night, raise the utilization rate of those GPUs. And the third one is extremely important. This one is around peer-to-peer capability, or think of x86 bypass. The idea here is in a normal environment, when GPUs are communicating with each other, normally what they're doing is they're going through the x86 processor, doing multiple memory copies, and GPU number 1 and GPU number 4 communicate with each other through the x86 processor. When we enable this peer-to-peer capability, we can allow these GPUs to DMA amongst their memories directly and bypass the x86 processor.
Can I just ask a question here?
Sure.
Is that a different approach? For example, NVIDIA is using NVLink or PCIe, gaming, whatever. This is a totally different approach.
No, it is not NVLink. It is NVIDIA's peer-to-peer capability. The difference is this: NVIDIA's peer-to-peer capability only exists inside the box. We're able to do that across multiple boxes, right? So the data that we'll share with you here is this is peer-to-peer performance run across 16 GPUs. When I have peer-to-peer turned off, I'm averaging 9 gigabytes a second. When I turn peer-to-peer on, I get a 300% performance improvement.
So if I get it right, with that you're going beyond the physical capabilities that you have in a for example, TU server. So you can extend that to what you would have, for example, add more cards and extend the peer-to-peer capability beyond
a single chassis. Mm-hmm. I can do it across 8 chassis, right?
Awesome.
The goal here is eventually to get to 64 GPUs in a rack, all doing peer-to-peer with each other. Mm-hmm. And in theory, the x86 processor is waving his hand saying, hey, somebody talk to me, right? And that's kind of the way that this whole thing is being enabled, mm-hmm. right? And so this is the throughput measurement, and this is the latency measurement, right? Some of these hyperscalers, latency is extremely important to them. Some of these financial customers, latency is extremely important to them. A 90% reduction in latency is not negligible. That's a serious performance implication, right? So the next category that we're playing in is what we refer to as cloud, or more accurately, dynamic cloud, right? These are customers who are either providing cloud as a service, some CSPs, or I am building my own cloud because I cannot go to AWS or public cloud for whatever reason. We give them the flexibility, we give them the agility, we give it to them on the infrastructure that they're owning and they're responsible for. This is going to be a growth area for us in partnership with the Dell team, right? We're looking to make a big splash in the cloud environment.
Okay, speaking about Dell, Dell has the PowerEdge MX.
Yeah, MX is great. We love MX, right?
What's your view with the Kinect?
No, MX is a road towards composability, right? Mm-hmm. And we're talking to Dell about how we can make MX even better, right? Oh, okay. So we're that little sauce that makes their servers better. We don't build any of their servers, but for example, the solution that we'll show you is we've taken R640s and we've built AI solutions built around that. We can build solutions around MX also. We love MX. We think it's a great platform. It's a great foundational hardware set to enable composability, right?
Okay, so does this go the same with HPE, Synergy, and?
Yeah, so I think Synergy is obviously the 800-pound gorilla in the room, right? They're the ones who define the term composability. We're slightly different, right? The way that we are different than those guys is, number one, we're disaggregated, right? All of my resources are individual trays of stuff. I'm not forcing you to buy CPU when you want to buy networking. We will sell you individual trays of resources. So we're disaggregated. They're more of a converged platform, right? We're multi-fabric, so I support PCIe, and what we're announcing earlier this week is Ethernet and InfiniBand composability. So I'm not limited to a certain fabric type. They're basically an Ethernet fabric, right? So, I don't know how you do GPUs over Ethernet, but, well, actually, we know how we do it, but it's an interesting problem, right? So choice of fabric's another one. We're an open ecosystem. My stuff is hardware agnostic. Theirs is more of a closed ecosystem. We're bare metal. I think that's one of the biggest ones, is when I give you an SSD or when I give you a networking card, I'm giving you a networking card and I'm giving you an SSD. A lot of what they're doing seems to be virtualized, right? And if you do, like I said, if you don't have composability without disaggregation and bare metal, I think it's more hyper-converged than it is composable.
Yeah, right. But they're like the first version, so it's kind of their own concept.
Great, and the way that we look at it is they're laying the foundation, and in our mind, there's no customer that we go to that says, this is stupid. Why would I ever want dynamic? That doesn't make any, it's always, tell me how you do it, tell me what the performance trade-offs are, tell me what the cost trade-offs are, tell me what new use cases I can do. So the fact that HP is running down this path, and they've been very successful with that product, make no mistake. I think HP said it's a $1 billion run rate for them now, right? So very big opportunity. That shows you there's market demand for dynamic infrastructure. Now, what is the rest of the industry going to do? The rest of the industry just can't sit back and say, we don't believe dynamic is the future, we're going to stick with static. That's not an option. So everybody needs to move in this direction. And the way that we look at ourselves is we're a physical hypervisor. I do for physical infrastructure what VMware is doing for virtualized environments. Just like VMware is, important across, many use cases, I think composability will be important across many use cases, and it's not just going to be owned by HP.
Right. Got it. Thanks.
Another use case for us is around HPC and clustering environments for a simple reason, the latency profile. When we talk about things like Ethernet and we say, oh, I got fast Ethernet down to 15 microseconds of latency, okay, that's good. PCIe latency is 150 nanoseconds. That's not 10x faster, that is 100 times lower latency. So if you want to build high performance, low latency applications, there is no better interconnect than PCIe. And one of the new features, we haven't announced it yet, but we're coming with it, is the ability to use PCIe as networking. So we have a software module, you load it onto your node, that software module presents itself as a 25 gig link or a 40 gig link. You speak to that just as you were speaking to a networking card. We're taking that data, encapsulating it, tunneling it over PCIe, and giving you the ability to have host-to-host communication over things like Ethernet without even having a physical Ethernet card in the system, right? This is our virtual networking feature that we're coming out with.
Would you say that you have a lot of customers that are looking at this type of solution because of the latency, or are they just really looking for that, that composable infrastructure and then realizing the effects of the latency after the fact?
Yeah, I think that's a fair question. I think it's kind of split down the middle. If you take the AI, deep learning, and HPC customers, they like it because of the latency. The dynamic cloud guys, and we'll talk about 5G Edge in a second, they're more interested in the flexibility, right? So our belief is the next set of data centers are not big boxes in the desert, and that's not where things are going to be built out. We think the next set of data centers are regional, small deployments, close probably to a tower somewhere, right? Close to the data. Sending the data all the way back to Nevada to get an answer is a long distance phone call. So we think the next set of data centers are actually going to be built at the edge. And what composability provides is utilization benefits. If I can take a rack that was utilized 20% of the time and get 40% utilization out of it, does that mean I can do with one rack what used to take two? Possibly. And if that's the case, that's what the edge needs. What is the edge restricted by? Power, cooling, floor space. If we can turn the utilization knob, we think we're a natural fit for the edge. The other side of it is, it's hard to send a human to the edge to move stuff around. If a GPU fails at the edge, send a guy with a van to the top of the hill to open that's hard, right? Sit back at your desk, recompose the infrastructure as needed. So we think 5G Edge is going to be an important growth segment for us, right? Okay. This is the announcement we made today, guys, right? This is around our collaboration with Dell, right? This gives the customers the ability to buy our solution directly from the Dell team. The other announcement that we made earlier this week was around multi-fabric support. So when we started, we were primarily a PCIe fabric, and that was the fabric that we controlled. Now this week we've announced the ability to support both Ethernet and InfiniBand. So as mentioned earlier, I can have a fabric that has GPUs and FPGAs connected on it, for example. Then I can have a different fabric that has NVMe over fabric. And I can grab the devices from the NVMe over fabric. I can grab the PCIe devices on the PCIe fabric, compose them into the same server. Single pane of glass, multi-fabric support, gives our customer the ability to go longer distances. PCIe does have some certain distance limitations where things like Ethernet can go much longer distances. PCIe has the latency benefit, but we can go now longer distances. So our goal is to give customer the choice, right? We don't want to pigeonhole them into anything. We want to work in their environment regardless of what the fabric type is. The next thing that will be coming, and as mentioned earlier, is Gen Z. We're working actively on Gen Z today. It's a little early still. The industry is quite not ready for it. Dell is a big believer in this Gen Z interface. That brings the next level of bandwidth and performance and even a lower level of latency.
So I'm guessing you give your customers guidance as to when they should use which type of fabric?
Yeah, absolutely. I mean, we make recommendations, and then it's up to the architect in charge to figure out what makes the most amount of sense for him. We're a toolbox. We'll give you the choices. We'll architect with you on what makes the most amount of sense. At the end of the day, you're going to have to decide: do I need distance? Do I need latency? Do I prefer Ethernet? Do I want PCIe? Right. Unfortunately, in this world, in this market, there's not a one-size-fits-all kind of environment, right? So we, a lot of times, customize these racks based upon what the customer needs. The mission for us, at least today, is not throw a switch over the fence and say, good luck to you, sir, right? We want to provide solutions. So that's why we're partnering with Dell. We're providing actually 3 solutions. The first solution is an AI solution. It'll have 8 GPUs, 32 terabytes of NVMe, and 4 nodes in a 9 RU package. We're showing that on the show floor. You'll be able to buy that as an AI bundle directly from Dell, right, to do all of your AI workflows. The next bundle we're coming up with is a GPU expansion bundle. As mentioned, there's a lot of servers out there, brownfield, and so what we're enabling with Dell is the ability to take a tray of GPUs, slap it onto your existing infrastructure, and augment it with GPU or NVMe capability. So NVMe expansion, GPU expansion, AI reference architecture, those are the 3 first items that we're taking on with the Dell team, and then we'll have more follow on for different verticals, cloud, edge, and so on.
So when you sell that bundle or you recommend it, I get the hardware. Do you also recommend the software stack as well?
So we have recommendations that say, hey, if you're going to run an AI workflow, here's some best practices that we've seen, but we don't provide. I mean, the only software we are providing is the orchestration software, right? That's what we're providing, and we have tools and guides and trying to educate the customer on best practices for things like AI. That's about what we do, right? We did, I want to say this is now a couple of months old. We made an announcement with Intel. This is around their Optane technology. We're partnering with these guys to enable composable Optane, right? So now I can have a tray of Optane devices, compose it into the server that I need, and then we also have the IMDT capability, which allows you to run that Optane as either very fast storage or DRAM.
When you're talking about Optane, you're talking about Optane, 3D XPoint as the storage media or as persistent memory?
3D XPoint as the media, and then we give you the option of either running it as persistent memory or as NVMe.
Okay.
Your choice. We also did an announcement with Xilinx, right? Composable FPGA. FPGAs are making a big splash in the data center. These are very expensive devices. Again, back to the same philosophy. If we can figure out how to give these devices to the servers that need them dynamically, we're going to get better utilization rate out of these FPGAs, right? So composable FPGA. And the reason why this is so possible for us is, again, how does an FPGA connect into the platform? PCIe, right? Guys, that's most of what I wanted to share. I'll share a couple of more market slides, right? We do see composability finding its way into a lot of different use cases. We talked about cloud, we talked about edge, we talked about HPC, we talked about machine learning. We think there's an opportunity here in the VDI space, right? We have customers today that are now starting to run things like vSAN on top of composable, right? We think those models make a ton of sense. If we take a listen to what guys like IDC and Gartner are saying is, they've drawn their box on where they think composable infrastructure, how they're going to count it, how they're going to measure it, right? In 2016, it was a very small market, right? In 2018, we hit $751 million of market opportunity. By 2023, this is going to be a $5 billion deal, right? There's not too many parts of the compute market that have a 600% CAGR, right? This is not a small growth segment. This is where the growth is in the server market, right? It's in this idea of composability and dynamic infrastructure.